So this podcast is about population growth curves. There are two learning targets listed underneath this. One, that I can graph and understand a population growth curve, and secondly, I can identify the carrying capacity based on the population growth curve. Now, in class today we did an activity, you guys did an activity on the computer where you were collecting data on population sizes of bacteria as they grew, and graphing that data, you realize that they followed a certain pattern, which we're going to talk about in just a moment. And then we're also going to add another vocab word of the carrying capacity. So what I want you to do is jot these down, and then I want you to highlight as best you can. I'm not sure how. Let me give this a shot. I'm not sure how well this will work, but I want you to highlight the vocab words that are in this, so we know exactly what the important words are. So a population growth curve is one. Let's see if I can make this a little bit bigger. A population growth curve is something that we want to make sure we understand, as well as carrying capacity. So those terms we want to know and be familiar with. So we're going to define those as we talk about these graphs together. Okay? So let's get started. So let's start with the first learning target, which is that you can graph and understand a population curve. Well, graphing is something that we're going to continue to work on, but I'm going to do my, that's not a good axis line. Let's imagine that this is going straight up and down, and we are going to kind of emulate as best as we can our curve that you drew in class for the bacteria, bacterial growth of the population. Again, a population is the number of individuals of the same species. So as you know, at the beginning of the curve, there's pretty slow growth, and then it grows pretty rapidly, and then it levels off. Wow, that's actually a pretty good graph. I'm pleased with. So there are three stages to this growth, and I want to break these down for you. Here at the beginning, we call this slow or gradual growth. Here, all the way, let's say that this is happening here from the beginning to about here, slow gradual growth. From this point to this point, we call exponential growth. And if you know anything, if you remember from math class, when you graph exponents, they increase like this. It's like if you graphed y equals x squared. So let's say we pumped in the number 1 for x. On the x-axis we went to 1. Y would also be 1, because 1 squared is 1. If x was 2, our y value would be 4. If our x value was 3, our y value would be 9, because we squared each time. And so that growth creates an exponential growth, and that's what's happening here. Growth is happening very, very quickly, and then up here at the top, where it's kind of level, we call this the plateau phase. Just like the plateau, a geographic feature. Plateau, it's flat on the top. And there's several reasons for this, and this is what you should know this as well. So this is what a population growth looks like. Let's talk about what's actually happening. Here at slow gradual growth, there are only a few organisms or a few individuals in this population. So they're not reproducing all that quickly. If we only have 2 individuals, they can only reproduce so quickly. But once we get a certain number of individuals in that population, they can be having more babies more often, or more offspring more often. We're not just talking about humans. Any kind of population will grow quickly because there are more organisms ready to reproduce or reproductive age, and therefore there's exponential growth. Now the reason that this doesn't keep going up exponentially, there's a reason that this does not happen, and that's because resources become limited. Now, those resources could be biotic or abiotic. And if you don't know what those terms mean, I want you to put stars next to them and ask me right before the podcast check on this. It's actually probably a good idea, even if you do know what if you think you know what they are, to ask so we can go over that. But we've got resources that are becoming limited, and so if there's only so much stuff that these organisms need, they can't keep growing infinitely. There's going to be some limit to how many individuals there can be in an environment, so it kind of levels off. So I want to ask you, what's happening? So what is happening to reduce the rate of growth? And you can still see that the population is still increasing, but just not as quickly. So that's what I mean by reducing the rate of growth. It's not increasing quite as quickly as it was here in exponential growth, and it's starting to reduce down. Now, because it's not growing anymore doesn't mean that the population is decreasing. We still have quite a bit of individuals here. It's just not increasing anymore. Now, just want to make sure that we have a complete graph here. On the x-axis, we've got time, and this could be in any unit. It doesn't really matter because all populations are going to look like a graph like this. So it could be in seconds, it could be in days, it could be in years. The scale doesn't really matter so much. Now on the y-axis, we're going to say the number of individuals. So as you see, as time goes on, generally the number of individuals increases up until the plateau phase when it starts to level off, and we don't have any extra individuals, but those that die get replaced by those that survive, those that are born into the population, or those that leave the population or emigrating out are replaced by some other individuals who are immigrating in, if that makes any sense. Alright, so that's target number 1. Now I'm going to actually, instead of redrawing all of this for the next target, let's talk about that one very, very quickly. I'm going to make this target 2. Oops. Target number 2 is about carrying capacity. And really, our idea of carrying capacity is kind of self-evident if you think about what that word means. The capacity of individuals, so carrying capacity is the maximum number of individuals in a population that can be supported by the environment. Okay, so that's the definition of a carrying capacity. We use the letter K for whatever reason to abbreviate it. And so if we're looking at this population curve, the maximum number is where the plateau phase is. The population doesn't really maximize or increase beyond this plateau phase, and whatever value that is on our y-axis, so the number of individuals that can be supported, is called our carrying capacity. And so oftentimes we draw a line straight across, and it's here in green, and this would be our carrying capacity. So if you can figure out the carrying capacity based on this population curve, then you've met the second target. And that wraps up this podcast.